Okay, so welcome to section 1.4, which is analyzing arguments. So analyzing arguments. Okay, so there are two types of arguments, so argument types. So the first type is called an inductive argument. So an inductive argument. So this uses a collection of specific premises as evidence for the conclusion. So uses a collection of specific premises, premises, yes. So as evidence for the conclusion. And the second type of argument that we will deal with here is called the deductive. Pardon me. Deductive argument. Okay, so the deductive argument uses one or more statements to reach a logically sound conclusion. So uses one or more statements to reach a logically sound conclusion. So to reach a logically sound conclusion. So that's what we're going to be dealing with here. So let's call these valid argument forms. So remember we had fallacies in the first lecture. So this would be the opposite to that. These are actually valid argument forms. So these, if you use them, they are good. Your argument is sound. So valid argument forms are as follows. So the first one is called modus ponens. Modus ponens, which is the mode that affirms. So the mode that affirms. Okay, so what we're given is we're given premises. So what color should I use? Maybe this color. So the first premise for modus ponens, we're given two premises. And you always assume that what's given, that your premises are true. And your conclusion follows from your premises. So for modus ponens, P implies Q. You're given P implies Q. So you have to assume that that's true. Because whenever we're using these argument forms, what we're given, our premises, are always true. We're also given P. So what it means to be given P is that we're told P is true. Okay, so an implication, what can we conclude? Well, let's look at premise number one. So, or both premises. So, premises. So what do we have? We've got P implies Q is true. Implies Q. And we know that that's true. So there's 3 possibilities, right? So let's analyze P and Q. P and Q. What possibilities do we have? True implies true. That's always true. True implies false. No, can't have that one. What about false implies false? True implies false implies true. That's also okay. False implies false. That's also okay. These are the 3 that are true, right? Okay, notice we don't have true implies false because that was false. But we also know from the premise that P is true. Okay, so let's look. The only case where P is true is here. So therefore my conclusion must be, what color should I use? Pink. My conclusion is Q. So here's my conclusion. The conclusion is that Q is true. So what we conclude must also be true. There's only one thing we can use if both of the premises are true. If P implies Q is true, and we know that P is true, then Q is true. So that is modus ponens. Actually, I don't like the way I wrote that. Let me make that arrow a bit different. A little bit less dramatic, shall I? Something like so. So we have that Q is true. It's the only possibility. Okay, so now let's look, or actually let's look at an example of this before I move on. So example. So I need 2 premises. I need an implication or a conditional statement, and I need that P is true. So the conditional statement, let's say if I go to school, then I will need to buy gas. So if I go to school, then I will need to buy gas. Then I will need to buy gas. So this is a true statement. However, until I actually go to school, I won't need to buy gas. So I went to school. I went to school. Therefore, what can I conclude? Therefore, I bought gas, right? Okay, so let's look at this. P, of course, is I go to school. So P is I go to school. And Q, of course, I will need to buy gas. I will need to buy gas. Buy gas. So if both P implies Q is true, which it is, if I drive to school, I'll need to buy gas. And we know that P is true. And how do we know that P is true? Well, from the statement, I went to school, right? So what can I conclude, therefore? Therefore, I can conclude that Q must be true. I had to buy gas, right? Q must be true. There's no way I could drive to school without buying gas. Oops, why is this parenthesis so difficult? Okay, so that is modus ponens. I don't know if I have enough room to do the next one, so let me just move this down a bit. Move that down a little bit. Let's see, there we go. Okay, so the next argument type that's valid, remember these are valid argument types, is called modus tollens. So modus tollens. Okay, and this is the mode that denies. So the mode that denies. Okay, so remember we're going to have our premises given and we assume them to be true. So premise will have two premises given. And then we will conclude something from that, right? Conclusion. Okay, so let's say we have our implication. P implies Q. Well, since it's given here, we assume that it's true. So P implies Q is true. And then we're also given that not Q. So if not Q is true, we'll have to figure out what that means. Okay. So let's look at our premises. Well, we know that P implies Q is true, right? So P implies Q is true. Let's underline this. It's true. So the only way for that to be true, true, false, false. I don't like the way I drew that. True, false, false. So true can imply true, but it cannot imply false. False can imply anything at once. Okay, so these are the three possibilities for the implication to be true. But we also know not Q is true, which means that Q must be false. So Q must be false. Actually, let me do that in hot pink. In order for not Q to be true, regular Q must be false. Well, there's only one of those. So what can I conclude? Well, I can conclude that P must be false. That is, if P is false, then what is true? Not P, right? So my conclusion must be not P. Because my conclusion needs to be true. So this is why we call this the mode that denies, because we have the negation of Q and the negation of P being true, meaning both P and Q themselves are false. Okay. So an example of this, the modus tollens, would be as follows. So for example, let's say I give you premise number 1 is if I fall asleep, then I'll be late. So if I fall asleep, then I'll be late. So this is a conditional statement. I'll be late. Okay, so what would the second premise be if we're doing the mode that denies? Modus tollens, not Q, right? So Q would be I'll be late. So not Q would be I wasn't late. I wasn't late. So my conclusion must be that I did not fall asleep. I didn't fall asleep. That is, my conclusion is not P. So we're going to have PB, I fall asleep. And Q will be, I'll be late. So we have I wasn't late, so not Q is equal to I wasn't late, right? Therefore, not P is going to be I didn't fall asleep, right? Didn't fall asleep. Modus tollens, the mode that denies. Okay? Okay, so the next type of valid argument is called a disjunctive syllogism. Hard to say, so disjunctive. Disjunctive syllogism. Okay, so this would be premise, conclusion. Remember, that which is premised is assumed true. Conclusion. Okay, so for this, we're going to have P or Q. So P or Q. So we're going to assume that P or Q is true. And then we're going to assume not P is true. So not P is true. So let's look at that. So let's look at our premises. So we have P or Q. And we know that that's true. P or Q. Oops, what's going on there? P or Q is true. So the only time that or is not true is when there's two falses. So as long as one of them is true, true, false, true, false, true. So these are the three times when the or is true. Why is it so difficult to draw V? I don't know. Just go ahead and draw it. Okay, so these are the three truths, but I know that not P is true. That means that P is false. So if not P is true, then P must be false. So the only time P is false is down here, which means all that's left is for Q to be true. Okay, Q is true. Why can I not draw a square around this? Or some sort of box type figure. Okay, I guess it won't let me. Okay, so Q is true, so that's my conclusion, right? So all I need to write is Q. Q must be true. Okay, so let's do an example. So let's just do premise. So premise number 1, I can either eat or do homework. Either eat or do homework. Or both. So I can eat or do homework. Let me just forego the either this time. I can eat or do homework. So that's my P or Q. My other premise will be what? Well, let's see. I need to have not P. So let's say I didn't eat. I didn't eat. So what is the conclusion? I did my homework, right? Is that what Q is, right? So conclusion, I did homework. Okay, so let's look at P here. I can eat. P is equal to I can eat. And of course, Q is I can do homework. Do homework. I didn't eat. So that would be I did not do P, right? So this is I didn't eat. Growl my stomach. I didn't eat, so what's my conclusion? Q. I did homework, right? Okay. So now let's do truth tables for a couple more things before we go. And they're known as De Morgan's laws. So, example. Now we're going away from the types of valid arguments. Okay, so number 1, let's create a truth table. Create a truth table for, let's do the negation of the whole quantity P and Q. And not P or not Q. Okay, so once again, I always like to start, we're going to have a lot of these guys. So P, Q, P and Q, not P and Q. Then let's do not P, not Q, then not P or not Q. That should be enough. Okay, so first let's do P, which we know is true, true, false, false. And let's do Q, which is true, false, true, false. Then let's do P and Q. So both of them have to be true in order for it to be true. So for P and Q, it's just true when they're both true and false the rest of the time. But now let's negate that. So let's do the negation of P and Q. Do I have enough room here? Let's see. I don't know if I do. Let's move this over one. Maybe move that over one. Okay, so the negation of P and Q. P and Q. I'm just going to change the truth value for everything in the preceding column. So that's false, true, true, true. Okay, so now let's look at not P. So not P is going to negate P, so that's now false, false, true, true. Similarly, if I look at not Q, that's going to negate the entries in the Q column. So it'll be false, true, false, true. Okay, so now I wanted to look at not P or not Q. That's why I had to write them right next to this here. So we're looking at these guys here, either or. So is either not P or not Q true? No. So this guy's false. Then all the rest of them have at least one true. So that'd be true, true, true. And I'd like to get that so that it's lined up. It's driving me crazy. Okay, true. There we go. Okay, what's interesting though is to look at the truth column here and the truth column here. Because it looks like not P and Q, not P and Q, seems to be equivalent to not P or not Q. Oops. So not P or not Q. That's interesting. Okay, so that's the first example. Let's do another example. Okay, so let's create a truth table. Create a truth table. For the negation. Well, last time we did an and, so let's negate an or. So then negate P or Q. And not P and not Q. See how those two are related. Okay, so once again, we've got our chart here. We'll have an entry for the P's and the Q's. Then we will have an entry for P or Q. Then we'll have an entry for not P or Q. Then we'll have an entry for not Q. Sorry, not P. Not Q. And then not P and not Q. So hopefully that'll be enough. Okay, so let's see. What do we have first? P, of course, is always true, true. False, false. And then Q alternates true, false, true, false. So now I want to do P or Q. Okay, so P or Q. Either one has to be true. So true, true, true. The only time neither is true is when they're both false. But now let's negate that. So the negation of P or Q. So what happens when I negate that? It now becomes false, 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 and true. Okay. So now let's go ahead and look at not P. So not P will now be false, false, true, true. Similarly, not Q will be false, true, false, true. And now let's see what not P and not Q gives us in terms of a truth table. Okay, so for the and, they both have to be true. So false, false, false. The only time they're both true is down here. So once again, let's look at this. The false, 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 true have an equivalent truth table. So that is, I have that the negation of P or Q is the same as not P and not Q. Okay? Simple. Okay, so these are known as De Morgan's laws. So let's look at De Morgan's laws. Maybe I should put a square around them. No, that's okay. I'll just write them formally right here. So De Morgan's laws. Morgan's laws. Okay, so the first of De Morgan's laws is if I negate an or, so the negation of P or Q, then I get the negation of P and the negation of Q. Similarly, if I negate an and, P and Q, I get the negation of P or the negation of Q. So these are De Morgan's laws. Okay, hopefully that makes sense, and I'll see you in the next section.